Alright, welcome to our fourth and final lesson on absolute value. We'll be talking about absolute value transformations. So you see here we got f of x equals a times absolute value of x minus h plus k. Now, I can't stress this enough. These transformation rules we will be using for every function for the entire class. So what you learn here is guaranteed to help you out for the entire class. So we got A, H, and K, and we're going to be talking about what those mean. So if you go down to Desmos, we're going to be talking about transformations. And if you remember geometry last year, we talked about translations, rotations, reflections, and dilations. That's what this is. So starting with the A, we're multiplying, right? So if you recall on geometry with shapes, that when we multiplied, we were doing dilations. We made things bigger or smaller, which, as you can see, if I make the A bigger than 1, it is stretching the V. I'm like grabbing it like a rubber band and pulling it. It is stretching the V upwards. And then, as V gets smaller, it compresses it and it makes the V wider. And if we make it negative, it does the same thing, but it flips over, and now it's reflected and it's upside down. So A, depending on if it's positive or negative, does both reflections and dilations, basically. Except now, instead of dilation, we call it stretch and compression. And then H we're adding and subtracting with H and K. So if you again recall from geometry, adding and subtracting always means that we are doing a translation. So if I make H bigger, then it slides to the right. And if I make it smaller, it slides to the left. But it's always just sliding back and forth. And get back to 0 there. And then the same thing with K, except take a wild guess which direction K will move it. It will go up and down. So H and K control translations and whether or not it goes up or down. So, an easy way to think of this is that you already know multiplying means changing size, adding and subtracting means moving stuff around. Another thing to think about is if it's inside of the function, inside of the parentheses or inside of the function, so in this case, inside of the absolute value bars, you are modifying the x value or the input. So H will always be moving left and right because you are modifying that x value. K, you're modifying the y value, so you're moving it up and down because y it goes up and down. And then A, you are technically modifying the y values, you're multiplying them, and that's what causes the stretch and compression. So let's go down here and fill this out. So this table is really the meat of the lesson. We're going to talk about what each of these things mean. So if you are adding K, you are doing a translation upwards. It goes up. If you are subtracting K, it is a translation downwards. If you are adding H, that is going to be a translation left. And that's a weird one. You're adding, so you think it would go right, but remember, if you look up here at our original formula, it is x minus h. So that means if h is a positive number, then it will be going to the right. And when we're subtracting, if h becomes negative, then a negative minus a negative becomes positive, so it looks like it's adding. So the signs on there are kind of switched. And then subtracting h, like I just said, is a translation right. And then finally, a, where a is greater than 1, that is going to be a vertical stretch. And then if a is a fraction, that's going to be a vertical compression. So stretch means that you're taking it and you're stretching it out and it's getting skinny. And if it's a vertical compression, that means we are taking it and we're smushing it and it gets wider. And then if a is negative, that is a reflection. It's going to flip upside down. All right, so let's try some practice with this. This is the type of thing that you'll see on the test. So it says, given the parent function, f of x equals absolute value of x, list out the transformations. So this says negative 1/3 of the absolute value of x plus 7. So let's start one thing at a time. What does the negative do? If you were paying attention, you should know that the negative is going to cause it to flip. So it's going to flip upside down. And then the 1/3, we're dividing, that is going to cause it to, looking at our notes, vertical compression. So it's going to compress by 1/3. And finally, let's look at the plus 7. Remember, if we're adding, we go to the left. So it's going to translate left 7 spaces. And if we want, we can always go to Desmos and double check this. So that says negative 1/3. So we're going to go into the negatives. We'll go to negative 0.3. There we go. So it flipped upside down and got wider. So we were right about that. And then h became plus 7. So remember, that has to be a negative value. So that's sliding all the way to the left. And then there was no k value in that, so k is just 0. So that's where that new graph would be, flipped upside down, smushed, and slid to the left. Now let's take a look at this next one. This says, given the parent function, list out the transformations of the function below. So this is interesting. This doesn't have the absolute value bars, does it? This says 2 times f of x plus 2 minus 5. The interesting thing here is that, like I said before, it's the same rules for every function. So this could be any function. The same rules still apply, and it's still the same format. Just treat the parentheses like the absolute value symbol, and it's the exact same thing. So starting with the times 2, times 2 is going to be a vertical stretch, right? and then by 2, right? Because we're multiplying it by 2. And the plus 2, that means we are moving to the left 2 spaces. Translate left 2 spaces. And the minus 5, that's a k, right? So that's going to be translate down 2 spaces. I just realized I forgot to say which direction the 2 made it go in. That's going to go to the left. And we can check that. Let's see what happens when we make A2 and H2 negative 2 and K negative 5. Oh wait, that should be going down 5 spaces, shouldn't it? There we go. Translate down 5 spaces. And let's double check it. So we're going to make A be positive 2. So there's our vertical stretch, made it skinny. And H is going to be negative 2. So now that's over there, it only slid 2 spaces. And K is going to be negative 5. There we go. Slid to the left 2 spaces, down 5 spaces, and got skinny. And now we're going to do the opposite. We're going to write equations that show these transformations. So we need to write an equation that makes it go up 5, left 3, and reflect. So we'll do these. I haven't used purple today. So we'll do f of x is equal to, we're not multiplying anything, but we are reflecting. So reflection means negative. Absolute value of x plus 3, right? Plus 3 because left 3. Absolute value up 5, so plus 5. And if you want, we can go double check that. Should be negative absolute value of x plus 3 plus 5. So this should be negative 1. And this should be plus 3. And this should be plus 5, right? Yep, plus 5. So left 3, up 5, and flipped upside down. Just like the problem said. So now in example 2, I'm going to do this without even double checking on Desmos. Given the parent function, write an equation below. Alright, so f of x is equal to vertical stretch with a scale factor of 9 and a reflection. So that means it's going to be negative 9 times x, and it's moving to the right 2 spaces, minus 2. So vertical stretch means multiply by 9, we got that. Reflection means negative, got that. Moving to the right 2 means subtracting 2 from the x value. And you can go check that on Desmos if you want. And write your own equation with the following transformations applied to it. reflect it, make it wider, and place the vertex in quadrant 4. Okay. So f of x equals something negative, we're reflecting it. We got to make it wider. So that means we're multiplying by a fraction, right? So I don't know, let's do 1/4. Doesn't matter. And then place the vertex in quadrant 4. So, looking at Desmos, so this means this is going to be negative 0.25. The fourth quadrant, if you remember your quadrants, we go 1, 2, 3, 4. So when it says place the vertex in the fourth quadrant, it's talking about take the point right here where everything meets, and we want it to be down here. So that means we're going to have to go to the right and down. So let's, I don't know, make this 4. 4 looks good. And let's take this all the way down to 2. There we go. And now it's in quadrant 4. So to do that, let's see, we changed the h to positive 4, so it's going to be minus 4. Close the absolute value. And then we made the k, made it go down, minus 2. So, subtract 2. And that's it. This one was a little vague, but that just meant we could fill in the numbers with whatever we wanted, as long as it went in the right direction. This says, write the coordinate of the maximum or minimum of the following function without graphing. Okay, so we learned about minimums and maximums last unit, and you know that it is either the highest point or the lowest point of a function on a given interval. They did not specify an interval here, so that means the interval we're using is the entire domain, all real numbers. So the minimum or the maximum, the highest and lowest points, are going to be wherever the vertex is, right? Because that's where everything meets. So we're trying to find that corner. Without graphing, well, I can tell you that it starts at 0, 0, right? It starts in the middle, and this is going to go to the right 5 spaces. Okay, so if it's at 0, 0, and we move to the right 5 spaces, that's going to become 5. And then plus 6, that means up 6 spaces. If we're at 0, then 0 plus 6 is 6. The vertex will be at 0.56. So, guess what? It turns out this number and this number are also always going to be the x and y coordinates of the vertex, which is really important to know. And we can check that. Let's make this back to 1. And then we'll make this 5. And this 6. There we go. The vertex is at 5, 6. So there's the exact same formula that the problem gave us. And the vertex is at 5, 6, just like I said. So the lesson is relatively simple, but it is incredibly important to remember, because without this, you're going to struggle with not just this unit, but every unit after this.